Going. So today we are going to make a tri-layer system. It's going to be graphene, molybdenum selenide, and hexagonal boronitride all in a single structure. So I'm going to show you how this is possible with LatticeMixer. So first thing we do is we go to latticemixer.com. We log in. Okay, so if you don't have an account, please make one. And what we do is we first go to our user profile and we're going to add some tokens. Tokens cap at around 25. Okay. Tokens are completely free. So let's go to our builder. So what we're going to do is we're going to have the axis that contains the vacuum, we're going to make that 30 angstroms. We're going to have a separation distance of about 5 angstroms between our graphene and molybdenum selenide. So yeah, the first thing we're going to do is make our graphene and molybdenum selenide structure. So graphene has a hexagonal lattice, and we're going to be looking at the 001 face of graphene. And also, we're going to be looking at molybdenum selenide, which is also hexagonal, and we'll be looking at the 001 face. So here you can see the variety of different heterostructures are made. So for example, like this one is fairly large, contains 180 atoms, it has nearly a 3% lattice mismatch. But we're going to actually take this smaller one here, okay? And what we're going to do is we're going to download this and save it to our desktop, and then we're going to use this file in one of our uploads here. Okay, so let's go ahead and download this. So download costs a token, no worries, tokens are free. Okay, so you can see here, here's our system. So it looks great. But now what we need to do is save this. So I'm going to go to File, Export Data. Let's go ahead and put that into our folder. So let's do, we'll call this graphene MoSe2 and save it as a VASP. And here, save it with Cartesian coordinates, okay? The program doesn't support fractional coordinates as inputs in the moment, but that's soon to change. So now just keep it as Cartesian coordinates. So you could see here, we just saved it, and this is what it should look like. Here we have Cartesian coordinates. So this is our system, okay? So now what we're going to do, let's head back to LatticeMixer. Lattice matcher, whatever, same thing. And we're going to have system 1. We're going to change this from graphene to be the graphene MoSe2 we just downloaded. And we're going to change this file to be hexagonal boronitride. So now what we have to do is add a little bit more separation distance, because the separation distance is going to be from the hexagonal boronitride to the center of this slab, of this heterostructure. So let's go ahead and press submit. And you could see now that system 1, we use the 1x1 cell of system 1, but the 1x1 cell of system 1 is this cell here, okay? So this cell is being interfaced with the root 7 hexagonal boronitride cell. And now it looks like this. So here's our first system, right? And we're using the 1x1 cell of that, and we're interfacing it with the root 7 cell. So, I'm right-clicking to drag here. So this cell here, okay, this cell and the root 7 hexagonal boronitride cell has a 0.1% lattice mismatch, which is pretty crazy. There are other options available. There's a huge one here. It's got a higher lattice mismatch, so there's no real reason to use this one unless you wanted to study a different system. But this one you can see is massive. Okay, and we could visualize both of these if you wanted to. So let's go ahead and actually download this one to see. Wow. So yeah, this one's pretty large here, pretty crazy. Looks really cool though. So yeah, the 8 angstroms here of separation distance, that's between this hexagonal boronitride and the center of this. Okay, so that's like about here. Anyways, let's go ahead and preview this one and download it, because this has 40 atoms. So this is likely the one you're going to use in your DFT study. So let's download it. Yeah, so here it is. This is our final system. Let's go ahead and expand it by going to boundary. I'm going to make this -1, 2, -1, 2, and apply. So yeah, there's our system. It looks amazing. And you could do this in any order you want. So you could have had the graphene in the middle. But yeah, these are really easy to make. And then what you want to do, what you could do is you could take this system, save it, and upload it here again to make 4 layers, right? So that's the way you could build these kind of layered structures with LatticeMixer. So let's go ahead and just compute how much distance we have in our structure between the layers. So I'm going to go to boundary. I'm going to make this 2, press apply. Okay, and then let's go ahead and let's actually shrink this back down, 0, 1, 0, 1. I'm going to go to bonds just to delete the extra bonds in the system. And let's go ahead and compute the distance between here. So it's roughly about 19, 20 angstroms of vacuum. So it's plenty of vacuum between the periodic images, right? So yeah, this is how you make this system. I hope this video was useful. It's a shorter video, so you know, but yeah, let me know if you have any questions or comments. When you go back to LatticeMixer, so we used a couple tokens, you can easily just add more tokens here. And like always, if you need a custom solution or anything specific that LatticeMixer cannot currently do, please email latticemixer@gmail.com. Yeah, okay, thanks everyone. Take care. Bye.